In this video, I'm introducing thermochemistry. Thermochemistry is the relationship between heat and other forms of energy with chemistry. So thermodynamics is the study of the relationship between heat and other forms of energy. Heat is commonly called the lost energy because a lot of times we don't get the work out of heat that we would like to get out of other forms of energy. So energy is simply the potential or the capacity to move matter. There's two major divisions of energy: kinetic energy, which is the energy associated with motion, and potential energy, which is the energy by virtue of position. So this picture of the dam here shows both. All this water right here that is in the motion of falling down off the top of the dam is undergoing kinetic energy. And all the water that's in the lake back here has potential energy. All of it has the potential to come over the dam. Now, interestingly, if you don't understand hydroelectricity, this is a dam that's used to produce power. However, none of this that you see here is used to produce the power. You see here you have a small offshoot. And so inside of this dam, there are channels that have big turbines, and you move the turbines inside a magnetic field, and that generates electricity. So the electricity generation is happening in this part of the dam that you can't see, and that water outflow is here. This water outflow just controls the level of the water in the lake behind it there. Okay. So the energy of units that we're going to be using this chapter is joules. It's at the SI unit. It's kilograms times meters squared per second squared. And a common one that we use is calories. And of course, you're used to the calories in food. However, the calories that we have in food is actually, so a food calorie, oops, that's not the one I want. A food calorie is actually a kilocal, or 1,000 calories. So and it's symbolized, instead of putting a K in front of it, a capital CLORIES is the kilocal, versus a lowercase calorie is that of this definition here. So 1 calorie is 4.184 joules. If we need this, I will give it to you. All right, and so the internal energy is another form of energy. It's the sum of the kinetic and potential energies of particles making up a substance. Okay, so it's the atoms. So you have bonds and you have atoms, and there's a vibration going on between all these atoms. There's a potential of the atoms breaking and forming. So that basically is what the internal energy is there. And the last part of this section is talking about the conservation of energy. Energy can be converted from one form to the other, but the total amount of energy remains constant. This is known as the first rule of thermodynamics. If you've had physics, you'll study the 3 rules of thermodynamics. And so this is showing a diagram here of where I have a very high potential energy but very low kinetic energy because it's not really moving. As the ball starts to move down the hill, it picks up kinetic energy. And so now my kinetic energy is very high and my potential energy is very low. And since these are the same size hills, as it continues to roll uphill, it's going to slow down, so it's going to lose kinetic energy, but that kinetic energy is going to transfer back into potential energy. And like I said, heat is considered to be the lost energy because a lot of times we don't actually get anything useful out of heat. If you think of your engine and your car running, car engines are only about 20% efficient, which means that 20% of the combustion actually moves your car. The other 80% is considered to be lost, and that's the heat that is generated by the car. It's not making the car move, it's just what is the side product of the reaction. And so that is this section introducing thermochemistry.